Shot, for the introduction, and thanks everyone globally for attending this presentation. Hopefully you can hear me clearly. All right, so the title of the talk, as Beshad mentioned, is the aging and reconditioning oil, a tribological perspective. This is a talk that most of it was given in at the STLE in Orlando, with some new data added here. So if you might, some of you might have already seen part of this, and we promise we are working, as actually I'm with my colleague here, we are working on the next set of customer and technical advances for this technology, and be presenting at the STLE, I think in California in next May. Like, so that's stay tuned if you like. The so the number of contributors to this, I just wanted to mention that, as I mentioned, I work closely with our business development manager, Anis Tajjananant, who is working with me here. But all the tribology work actually done by Arnaud Roland. He's at Netherlands, SKF Netherlands, and he's done that. And the Aldara Nevera Soares is kind of oil and chemistry manager and technical manager for this RecondOil. She's in Sweden. All right, with that, let's go into the our presentation. Let's see if it switches. Okay. All right. So in terms of the industrial lubrication oils, there is a lot of it used. I think so most of you are very familiar with that. Here, just showing like 19 million tons indeed, and this could be even more as in terms of time now. And this is showing like these super tankers that be full of the industrial oil that is used annually globally. And well, obviously it's very crucial to making the industry work. However, what we want to look at the way people have looked at traditional terms lubrication and industrial lubricants in particular, we want to kind of change the mindset and look at this oil as an asset as opposed to a disposable commodity. And I'm showing here, for example, the a typical oil cycle, if you like, starting from the original state at the higher oil quality, and then it goes to whatever process it is, and then takes degrades over time, and then the oil basically is being disposed of into new oil, and then we're going to do this multiple disposal and use in the system. But a couple of issues with that. One is that obviously we are in the era that everybody is looking for sustainability. As you know, this COP27 is ongoing, and everybody trying to find a way to contribute in any measures that they can. So this is obviously not a sustainable way of doing this. The other thing is the quality of the oil as it degrades is also going to change the performance of the processing equipment that you have and use that lubricants for. And so obviously also there's a cost involved with doing all that. So ideally, once one want to be able to continuously use the oil as this original state, if possible. Obviously, there are things that can happen in terms of specifically additives and degradation that it still cannot be maybe controlled in some circumstances. You want to then maybe go with this extended change of the oil within this period. So you want to extend that, and by that, achieve some of those goals that you're talking about. And as you all of you pretty much know well, that in terms of the contribute factors to the oil degradations are contaminations that's come from the process, the oxidation that happens because of the thermal or high pressure or other type of presence of oxygen and air in the system that you would degrade your oil, and the additives are consumed, and then this whole cycle occurs. All right, so what SKF has done over the past, I'd say, number of years is look at these this technology called DSD, or double separation technology. This is a company that we actually acquired a number of years ago, as I mentioned, and then by that, this is a oil reconditioning unit that once runs in its all SKF factory. As you see, it's a fairly large equipment, and this is installed in a very large oil reservoir. And here is showing that for every cubic meter of oil that is being regenerated, there is over 3 tons of CO2 is being conserved. And we have, as I said, a number of these in our facilities, both this large, and then we have the smaller version of them called small integrated, and then as well as we have what's called the standalone system, which can be operated at the side, and you can bring the oil and recondition there. We also was very excited to essentially launch a kind of a compact version of this, if you like, in this form. This, we call it RecondOil box. And I'm going to go through some of the mechanics, but basically the idea was to bring that technology into a compact form that can be adopted by customers for many operations. And it comes in many different forms, but this is actually even have higher equivalency of CO2 reduction per cubic meter of oil that is run through this unit. All right, so again, just to say the potential areas of this circular use of oil or extended use of oil would be total cost, oil cost reduction. That is, I guess, is very obvious to everyone, especially with this increased cost of lubrication, and everybody kind of suffer from that, as we all know. Performance improvement, as I said, if the machinery can run with a lubricant which is kind of as close as new, then it's going to perform much better in terms of whatever application, being hydraulics or otherwise. And this sustainability kind of angle and the reduce emissions that can contribute, even though small, but it can contribute to each company's target goals in terms of sustainability. All right. So let's kind of move into the what we have for the talk today in terms of content. I'm just going to go talk more regarding the describing what the RecondOil and this double separation technology consists of. And then we're going to go and look at the tribological verifications of that, because we have to make sure that the oil is treated this way has no impact negatively and hopefully positively in terms of what we can see in terms of friction and wear and other aspects of this. And then we give you some of these examples that have been done in the facility I mentioned in Netherlands by Arnaud, and then we're going to look ahead in terms of the some of the things that we have already done and some of the things that are ongoing and coming as we go to the remainder of this year and forward. As I mentioned, we have another talk that is planned for the next STLE. Okay, so let's focus on this recondition oil, the double separation technology, and explain a bit more for those who are not familiar with the concept. So this is called double separation technology because it has two combination of a chemical and mechanical process. So the in here, what we have, it's a patented technology. It's called we call it chemical booster for lack of better more description of that. Is that's being added to the oil. This very attractive to many of the contaminants that are present in the oil. But the first thing we have to do, sorry, let's see. This booster has to be mixed with this oil. So there is a process of mixing this in, and a lot of the technology we have around proper droplet size and all that it has to be done properly. Once it's done in there, then the next is to essentially, once it's mixed with that, then it's going to start attracting all the contaminants that are within the oil. These all kind of different sizes in terms of the contaminant size, and once they agglomerate, once they kind of agglomerate on these particles, attract to the particles, then the whole system start to agglomerating, and you get this bigger booster droplets coalesce together with the contaminants, and then you can actually settle or you can separate them in different ways. And you would have this top phase, which is has very low contaminant level, and that's still going to go through a separate filtration to be remove the I guess the last remaining contaminants. But what we, as I mentioned, with what I'm showing this last part, is also the RecondOil box technology, which we included this booster in, and put it and impregnate the filter in there, so we can achieve this double separation technology with a filtration system, which is very convenient in that sense. And just to say, in terms of the type of particles that we can remove, they could be from anything in terms of the wear particles that come from the process, like iron or other things of that nature, metal particles, degradation product that come from the oil itself, demonstrate themselves in terms of varnish or soot or others, and fluid contaminations. Water and others can be all very attracted to this booster because of its chemical composition. All right, so one thing that we wanted to emphasize here in terms of the effectiveness of this system versus other potential system that exists is that it can go into really submicron and nano particles removal from the oil, and this is kind of a statistical distribution of the particles within I think within any system, but in the oil as well, that there's a 80% of the particles would be in the submicron region, and the issue with that is, as you know, like in terms of the surface to volume ratio, there's a much more surface to these nanoparticles, even though they are, and submicron particles, even though they're small. And chemistry, as you know, is really driven by the surface, and so when you have a lot of the surface of these contaminants within the oil system, that can really degrade the oil at much accelerated way, and that's where we like to bring the benefits of DST, which can really tackle that and remove them from the oil in that way. So just going again, wear particles, catalyst for oxidation, and these are all we're gonna see in terms of the application of DST, in terms of varnish, additive consumption, and maintaining of the viscosity. Okay, let me show you some examples of what has been done in terms of the various oil of honing oil, hydraulic oils, or quenching oils. That these are the MPC standard ASTM patches that you can see on the left and right in terms of the before the used oil as it was, both, and the ISO numbers are shown at the bottom there. Some of them are fairly dirty oils in terms of numbers you can see. And then the patch itself is clear that the application of DST has significant improvement in terms of the the particle counts. You see up to maybe 9 or 10 orders at times it has happened, as well as the what you see on the patch itself. So that's very, very effective. But interestingly, since we're talking about nanoparticles and also these soluble varnish, the patch size is 0.45 microns. So anything smaller than that, you would not see, like in typical this patch test, the standard ASTM test. So we have actually developed a in-house patch test, or MPC method, kind of modifying this, where we're adding the booster to it, and then you can see the difference in terms of what was actually in the oil in terms of the soluble varnish, and then we can bring it out. And this is, I think, quite drastic for this demonstrating this phenomena. In this case, the same oil, it was done, compressor oil, which was done let me just see if I can get the cursor. Yeah, so this was done the standard way, and now they can see again, ISO code didn't really change, but when you look at these in-house patch method with the addition of the booster, you can see that it dramatically changed the picture that you can see. Another study that was done looking at what effect that DST has on the thermal stability of the oil. This is a good study done on a high viscosity 320 centistoke oil, and we deliberately added submicron iron oxide particles to the system. And let me see again my cursor here. Starting with the purple line here. So just sorry, one of the things I would say, the way the test was conducted, that these 3 flasks, one as it was new oil, the other one with this 2000 ppm of iron oxide particles, and the last one was the same thing but being DST treated in 3 flasks, and they were put at 150 degrees C. And then we're looking at the oxidation level as well as the antioxidants in the oil. So let's start with the purple one here. As expected, you're gonna see that, and so we are first. Let's look at the left here. The oxidation would go up over the time. This is hours that the sample was in there. So there's some increase in the oxidation, and as expected, there is corresponding reduce of antioxidants in that oil. The one which actually interesting is the one that had 2000 ppm of this iron oxide particles, and here in this case you can see it really shoot up in terms of the oxidation because the antioxidants is becoming consumed in this system. As you can see again, it goes below, it shows there. But when this oil was treated before this going to the aging, with the DST process, the picture changes, like this yellow showing that we actually pretty much bring it back to this state of what the new oil was. So the both in terms of the thermal stability and in terms of oxidation or antioxidant level. So again, it kind of demonstrates that these submicron particles can be treated in the oil with this DST process, and removal of them would help the health of the oil. All right, so let's kind of now move into the tribology part of the discussion, because this is the forum that is for it, and it's very important that once we do this treatment, that we are not affecting any way negatively this performance of the oil, because at the end of the day, those properties are good if the oil can perform in the real application. So areas that we have been focusing in terms of this DST technology, metalworking is one of them. As I mentioned, in our own plants, and I'm going to have examples of that again, use of this technology. We have being SKF making a lot of, as you know, bearings and all that can be like honing, and that can be used this technology. Hydraulics is another focus of ours in terms of oil system there. This is, for example, maybe particle counts is not as much of an issue. Rather, the varnish can be very detrimental to the health of the various machines like injection molding and others. And the one that is obviously very close to SKF heart is the lubricating oil and use of it in bearings and so forth. And that's where we're working on. We're getting more data, and this we have examples in this talk, and then we're doing more work around that to getting the data that we need to show the performance of that. So that's the kind of our challenge as we go forward. All right, so let's kind of move to the setting up the how we do this tribology verification. So we have the three types of oil, as we mentioned, new and used, and this reconditioned, which is basically this DST treated. We can see at times that this visual improvement in terms of color, but not always. And color is one indicator, but really one needs to do much more a better way of characterizing the oil. And so we do a whole set of tests in terms of the basically physical chemistry of the oil, the viscosity being the indicator of the oil being suitable for the application. We look at the composition of the oil by various ways of like XRF and ICP to make sure the additive content, although it's not 100%, because we don't necessarily know all the times what is the additive package that is that is used. The contaminations, we looking at the particle counts, the iron particles, the PQ, the patch test, as I mentioned, measure also the water content. And oxidation is measured various ways by FTIR, total acid number, ruler number, the RBOT, and that. So we're looking at all that in terms of characterizing the oil basically as it was and after being treated. In terms of tribo testing, these are again at our facility done in Netherlands. So the typical, the MTM ball on disc, where the coefficient of friction measured, is also measurement of, or the camera to view the tribofilm layer that is formed. For wear, again, the standard 4-ball machine is used, which there is has its own limitation. We also have the in-house methods, and so this is better controlled that way. And we look at the wear mode in in that, both in terms of kind of micro pitting and the macro and micro pitting, and we can characterize them in different level of kind of good micro pitting, medium, and severe case. And after that is also we have smearing test that we would do with the look at the traction coefficient, and where basically you get this welding that would results into this very high increase in the traction coefficient. This is actually showing the all the samples that either new, used, and reconditioned, they had similar behavior. And all that would give us kind of a bigger picture, all this information in terms of now what we can do for real, if you like, application testing, in terms of the FZG or FEA test and others that's require a lot of money and time to do. So having these tests done, we have a good indication of is the process suitable for doing this type of testing, application testing. All right, so let's just move on to some examples of the studies that have done. The first one being a compressor oil, which was this air compressor, and it had a reservoir of 72 liters and at 85 degrees C. And in this case, the oil was taken after 1,000 hours approximately, and the whole normal drain is about 8,000 hours. So it's, I guess, somewhere in the early stages of the use of oil. You see already that has been quite dark used, and then the use for DST, the color really didn't change as much. So that is, as I mentioned, color is not the entire story. But one thing here which was really significant to look at was the, I mean, particle counts, and that didn't also change much. But oxidation indicators, all of them, there was very, very much improved looking at the, so by FTIR, we basically where in terms of the use and where it is after treatment. This RBOT, in terms of that, it's also came back very much similar to what the new oil was. The MPC rating, it was, I would say, good, but we got much better once treated. And the same goes with total acid number. It did decrease after treatment. So those are very good indicators in terms of the oxidation byproducts, the reduction in this oil that was tested. Given even that there, in terms of the additives, that there are some that are consumed and we are not really replenishing them, because this was already through the process. So the concept that we like to propose to people is that it would be great to have this reconditioning done from the time that oil is new, so that you can keep everything at that high level without really degrading them. So friction performance, this one showing at different slide to roll ratio at different temperatures. Basically all three perform similarly, and this was at 10 and 50% at those three temperatures. And so that was kind of, again, indication that the DST process has not really changed that, which is good. We saw some improvement actually in terms of wear performance. This the 4-ball or that in-house wear test that I mentioned. And in both cases, you see some improvement in wear performance. Despite that, the fact is phosphorus was lower in the used and used plus DST sample. And then the smearing effect is also was pretty consistent with this. This is also in-house that is measuring that smearing. I forgot to mention that. but that all three is done at different temperatures, so they're all performed similarly again. All right, so have another example, and I am going over time, but hopefully it's okay to have time with
Go
this.
ahead. We have it up
Yeah.
to 11, so go ahead.
Okay. So I am taking the most of the time that was allowed. So all right. Um, so the next example is about a wind turbine gearbox oil that was in the service for 7 years. So that has been there for a long time, and here's the kind of the physical and friction, everything kind of summarized in this sheet in as the one can see. One of the interesting thing was the viscosity was essentially restored, like it was um, the used oil had high viscosity, and once this was treated, the viscosity decreased. There's some improvement in terms of particle counts. The elemental analysis again is something that we are not topping up these oils, so they are as they are. There in terms of the friction, so there wasn't really much difference between the MTM results before and after. In terms of wear, we did see some increase in wear with the actually the use plus DSD. However, but what we did then, the just as I guess saying these numbers again, friction performance maintained. Um, so this was something we had concern about the friction in terms of wear. I mean, but then we did the full bearing test, this test that is mentioned here, and it determined that they're all performant satisfactory, and so it that further test did not raise any worrying indicator regarding the wear. So again, that was positive to see. All right, with that, let's kind of move to the last part of the our talk today in terms of where we are in some current successes in real life and planning we have regarding this more compact form of the RecondOil DST technology with this RecondOil box. Um, so first example is this is a large DST installation in running in one of our manufacturing facility, actually in Italy, Casino, I believe. The it's using it's a honing oil that used in the bearing production, and is being as you can see kind of the this is showing the gravimetric test for the so residue on the filter. uh, they have a dirty tank, clean tank, and so this was how it was in terms of these are milligrams, uh, but I think per liter or per 0.1 liter or 100 mil typically. Um, so it was kind of pretty widespread, and it was high. And then they installed the DST unit as where this red is showing, and everything kind of the dirty tank and the clean tank, and then right after the DST, they're all really decreased, and so that was very good for the production manager and the plant manager to see that. And these are actual metrics that they observed, like in terms of the those three items that I showed before. For oil consumption, they reduced the oil consumption by 55 cubic meter, which translates into the saving of the CO2 around 150 ton. And they had 40% scrap reduction for the parts of these bearings that they produce. And these are some other metrics that they look at in terms of the variation in the quality of the surface of the bearing and that. So they really managed to bring that to much more manageable and controlled way, to a point that actually they were doing this process is a grinding, honing, and washing and assembly. They were, because of this data they had, they actually managed to eliminate this washing step, which was, you know, in terms of cost saving, in terms of ease of operation and other things, that was really a very good outcome. Here I'm showing kind of more recent studies that we have done, and as I mentioned, we are doing much more. We have another paper coming on that. Like, so these are going to be the case that we looked at. This is a third party kind of facility that we run this very aggressive hydraulic oil being under test conditions, and these test conditions were very severe. Like, you have running this unit at 200 kilometers at 80 degrees C, and then you change that to 60 kilometers and 110 degrees C, and with very high pressure above 200 bars. So then looking for leakage, for friction and wear. And what they did was they ran these 3 test cycles, first with this, what I'm describing here, and then the oil after that was done 2 different ways. One was then these was as is, went to a test number 4, and the other piece was this after test 3, it was gone through a DST cleanup process, this hydraulic oil, and then it was able to run it again for at least 2 more cycles. And you can see, like, the difference between this after this test 4 after 2, the difference in terms of this aging friction force, average friction force is showing how wide the band is, and this is for the 2 cycles, the 200 kilometers, and then this is the 60 kilometers. And so this oil was not usable after this test anymore, so it was deemed that is basically has to be disposed, versus this oil that was a DST treated. As I mentioned, it had to go to multiple other steps or multiple other tests. So really increased the oil life, which is it's very desirable. As I mentioned, this is a one-time treatment, so it's not a continuous treatment. So you want to imagine continuous treatment would be even do this more. You can do more cycles if you like. Okay, so this is just a bit of just to show you what this new DST version is. It's basically for gearbox oil would be the same as in a kidney loop, and it just connects to the oil reservoir, and it would run at whatever flow rates that is being set up at, and very kind of easy to use and everything. And the functions are mentioned here. It's as similar to the large units that I described. Essentially, the idea to do this nano filtration or submicron filtration, removal of varnish, and capability to remove some water as well for the system. Although if you have a very high water content, we suggest that you use a kind of dewatering system prior to use that. And yeah, there are 2 types of filter that are available and used interchangeably afterwards, so they're very easy to go. Like, typically we start with just a mechanical filter, depth filter, very effective, as it's shown in terms of the various capability. It still can go submicron, but not as low as the this DST activated filter. It can then do insoluble varnish versus the soluble varnish, as I mentioned, as I showed to you with that patch test. And the water removal is also very again, more effective for depth filter. With a DST activated filter, we don't want high water in the system. Really, you want to tackle the dissolve water using the DST activity filter, because water has affinity for the booster itself and can bind those sites that you like to have for contaminants and varnish removal. We have many of these DST RecondOil boxes that have installed in different places, both at our own sites. We have just right now, actually, we're running one in our own facility in SKF here in Dorval site near Montreal for a customer test. But we have many cases that is coming. You can go to our website for SKF RecondOil, and you can get examples of these application that has been done, and it's just adding to that information on frequent basis. So with that, I really wanted to thank you. Appreciate that you put the time. I know everybody's so busy and that. So hopefully it was useful to introduce this technology to you, and it'd be great to hear whether there is any opportunity to work together or anything you have from myself or Anis. Be happy to hear from you. So with that,
Thank you.
I guess I stop. Yeah.
Oh, thank you, Sassan. Thank you very much. We have 4 questions so far in the chat. I think you answered probably a couple of them, but I'm going to ask them anyway. So if
Okay.
you need to add more, please do so. The first question is, what type of booster formulation are available and what do they target? And I want to add a little bit myself as a question. Is this something, these boosters that we buy off the shelf, or there is more work into it?
Yeah, so booster is a good question. As a chemist and chemical engineer, I would ask the same question. It's actually a patented formulation that SKF acquired once they got RecondOil. We have our own chemists who have developed new version of it, different viscosity and so forth. For example, RecondOil box is a bit different from what we have. Chemistry is the same, but physical properties are a bit different. Basically, what all I can say, and as I said, like it's I can't go into the details of it, unfortunately, but what it is, it's a fairly it's a polar compound, and this polarity of it would attracts most of the um, you know contaminants within the system, being say metallic or say oxidation byproducts and others who are attracted to it, as well as water to a certain extent. That's the and one thing we do, by the way, I should say, is that we, before using an oil, like say for DST, before we test that, like we test that, and then we send this oil to a third party lab where they can actually look at the results, and including making sure there's no incompatibility either with the oil or the additives.
Okay, good, thanks. The second question is, how does this system handle dissolve degradation products?
Yeah, that slide that showed the idea was that with this I guess the MPC in-house patch, which I showed, those are clearly not in the system. At least they were either dissolved or below 0.45 micron. It can attract those as well in terms of the byproducts that it would bring them into becoming insoluble and agglomerate with the booster. So that's what do we remove everything? I can't tell you, but we have seen definitely evidence of something that you could not be captured in a regular MPC, and we can do that with the this booster technology.
Good, good. How about additive depletion? Does it attack or attract any additive package?
It's a very good question, and very legitimate question. What, as I said, we do test the compatibility, treatability, if you like, with the oil first. Um, so in those cases, if there is a incompatibility, we would say the chemical component booster is not suitable. Uh, as I showed you, like we have also the depth filter system, which is still very effective. And those cases, we recommend that the customers look at that option, and like I said, still fairly active, fairly effective. The
So you take the oil sample and you check the compatibility first
right,
before you
right,
recommend it.
right, right. We
And
do, and then we test it, and we look at the additives, and we see whether there's any substantial decrease. If that's the case, then we would say it's not uh, suitable for that application. So we have to look at the more depth filter for that. Yeah.
okay, okay. The next question is, I think you answered that, but where we can go to find published studies, white papers on the
Yeah.
Recon DST
Yeah.
system?
Very good. Like we have, yeah, like if you go to the just in Google and that, like put SKF RecondOil, um, you can see there is a wealth of actually information there in terms of the technology and all that. So I actually had it. Let me see if I have. Yeah. The no, this. Yeah. So we I can definitely share that with the group afterwards. But yeah, SKF RecondOil. It's you type it in, it has that, and marketing, and as well as the white papers. We have a number of them published. Yeah,
So what I do, Sasan, today afternoon, I'm going to send an email to all the registrants with a link to this video. So if you want to
yeah,
send me a link so I can add it to that email and send it to everybody as
absolutely,
well.
absolutely. That
Thank you.
would be great. Yeah.
Okay, so the next question is the booster a consumable product? If so, at what frequency is it required to replenish it?
Okay. Um. So the answer is yes. It's used, but in terms of the uh, RecondOil box, it's already being impregnated into the filter system by again a process we have here. So that is, you would not do anything with the booster. It just would be the filter. This filter is changes these and so you would add, for knowing what time, for example, you would change the filter is similar to other filtration system. And we would do that condition monitor and that to know what's the right time to do that. For the large system, we should talk. Yes, we would have it would be coming in, it's a liquid contain, would come in that form, and but we would be involved in that part. But for the small RecondOil box, there's basically no separate booster as such. It's just as part of the filter system already.
Normally in big system, what's the ppm of this
Is in
booster?
the in yeah in we adjust that, but it's like in less than, say, around 1,000 or less, or like that kind of, so it's fairly low.
Okay, okay. And when you say large system, a small system, what's the threshold?
Okay, so threshold is based on the liters per day that they can operate. For example, that large units that I was showing in this, that one was 8,000 liters, I believe, per day. This one, yeah. The and but on the sorry, uh, the for the smaller units, we are actually improving. It was what, a few hundred, like 800 liters per day, but we improved that. It's more around 2,000. So so let's say about um, 2 to 3,000 liters per day for the smaller integrated units, and it's like over 8 to 10,000 liters per day for the large units.
Okay. And we see only, or I see only a gray box. If you are sharing something on your screen, we don't see that.
Oh no, sorry, no, sure, no, I'm actually no, I'm Yeah, no, I'm not sharing.
Okay, you're not sure. Okay, so the next question is, I have read about EPT, clean oil technology. Is there a huge difference between SKF recon oil technology and EPT?
Yes, I mean EPT is they are using this I guess the resin exchange system and that like so that uh, ours we believe it's more uh, effective, but they have this that's a more traditional way of kind of resin system that you would have that you would do. Removal of various liquid that goes like ours it's a more, as I said, this chemistry is different. We believe it's going to a submicron and nanoparticles. Haven't I don't I guess I'm not going to say something negative about their system in terms we have one has to look at it side by side, but um I think our system, in terms of what we have seen, submicron particles, varnish removal is very effective. So, but they are having this exchange, resin exchange, which is different somewhat from what we do. It's not um, quite the same mechanism.
Okay, good. So the last question that I have in the chat is the DSD suitable for turbine oils, thinking about the effect of the polar booster on
Mhm.
demobility?
Yeah, no, that's a good question. We actually are working with the customer on that, and we um, we need to look at that. It's I know that the those are relatively large molecules, and so we have to make sure that we are is not removed. But what we have seen so far is positive. But I think it's probably we need to talk more specific on the actual oil. And we would, as I said, we would do a test before, and we look at the removal of any demulsifiers in the system as well.
Perfect. Okay. So I don't have any more questions in the chat. If in the audience, is there any question, please unmute yourself and then ask the question as we have Sassan here. So thank you, Sassan. It was great pleasure to have you and go through this new technology that you have. And cost-wise, just waiting if there is any question, but cost-wise, how much it costs to put a small unit in a plant?
Um, we actually that would be more and this is area. So, but what we like to do is actually two approach. One is would be more on the, I guess, potentially transactional system, but we also like to offer a more a service oriented approach, because we want to be part of a kind of an ongoing project with that. So we have a very attractive service type or subscription type, if you like. And I mean, I don't want to say a price here, which is and it's changing, but we definitely have both options, like both transactional and then more service model, especially if the DSD system is involved, because we do condition monitoring, we do all the commissioning, we look at the any change of filter, all that. So it's a bit more convoluted that way.
Oh, perfect. Okay, so I don't see anybody unmuting and asking question. Is there anything else, Sasan, that you want to add before we conclude the meeting?
I just wanted to thank all the audience and everybody who attended. Hopefully they find something useful out of this, and please reach to us if you have more specific question, or if you have an application that you think might be suitable for this technology. And we have a process that we would take samples. We do the initial part, and then we would process this in our facility, and we can work together to see whether it's suited for you. So again, thanks everybody for attending this webinar.
Oh, thank you. And there is one last question just popped up. Who can we reach out to propose an application for one of our sites. So they can contact you, Sassan, right?
Yes, me and Anis, but yes, contact me and then we would get back to you and probably ask some specific questions and all that. Yes, please. Yep.
Sassan, if you don't mind, I put your contact information in the email that I sent out. Is it okay?
Absolutely, please. Yeah.
Okay. So Brian, I'm going to put Sassan's contact information in the email today afternoon. So look for that email and you will have his contact information. Okay, Sassan, on behalf of Staley Toronto section, I wanted to thank you for the time and the knowledge that you gave us today. And I wish everybody a great Friday and a great weekend.
Yeah.
Thank you.
Thanks again. All right.
Thank you. Bye, everybody.
Bye-bye.
Thanks.
Bye.
Thanks.